আগের দিন যেখানে শেষ করেছিলাম, where we actually ended up in the previous class, that was the two necessary and sufficient conditions for flight stability in trimming condition.
স্যার স্ক্রিন শেয়ার করেছেন কি?
করছি দাঁড়া।
আচ্ছা স্যার।
So those two necessary and sufficient conditions had been these two. Tm0 must be positive and del CMCG del alpha must be negative. All of you remembers or not?
Yes, sir.
Okay. Now, as far as the condition prevails that the tail with a negative lift will be there in order to achieve this particular thing. But what are the specific relationships that actually ensures that this particular thing will be achieved? Now let us see. First of all, consider the wing only the wing. I am showing you the total figure again. This is the total figure, and of this particular thing, consider the wing only. So if you consider the wing only, then for the wing only, there are lift of wing, drag of wing, and the moment about aerodynamic center of wing. These three force moment combinations are there. Yes or no?
স্যার লিফট বললেন, ড্র্যাগ বললেন, আর কি একটা?
কেন মোমেন্ট অ্যাবাউট এরোডাইনামিক সেন্টার সে তো থাকবে, এমএসসি উইং।
ওকে স্যার, হ্যাঁ স্যার থাকবে থাকবে। স্যার স্ক্রিনটা কিন্তু দেখা যাচ্ছে না।
হ্যাঁ
স্ক্রিনটা দেখা যাচ্ছে না স্যার।
সে কি কথা?
দেখা যাচ্ছে স্যার।
দেখা যাচ্ছে।
চন্দন ঠিক করে দেখ।
স্যার স্যার এক মিনিট স্যার, তাহলে আমি রিজয়েন করি আগে।
হ্যাঁ রিজয়েন কর, স্টার্ট করছি।
ওয়েট স্যার।
দাঁড়াও রিজয়েন করে বলুক, বাকিটা বলছি।
हाँ sir, now screen is visible sir, clear sir.
Okay, so you may see the moment about aerodynamic center and the lift and drag at angle alpha wing. Alpha W is alpha wing, and as I mentioned in the previous class, from now onwards, for my flight consideration, every angle of attack is
Absolute one.
Absolute one. Okay. So the moment about the CG for this consideration is obviously provided by this particular equation. Just follow this particular equation. MSEW will be there. Fine. Lift will have two components. One is the vertical component and one is the horizontal component. The vertical component is at a distance of H minus HACW into C. So you guys please see at the 5 components of MCGW, and if anybody is having any problem in it, please let me know. And if all are convinced, just tell me to continue.
DW টা কি বলেন?
আর একবার বল।
DW টা।
DW is the drag for wing. Any other?
না স্যার ক্লিয়ার আছে স্যার।
স্যার ওই উইং টিপ থেকে এরোডাইনামিক সেন্টার অফ যে লেন্সটা আছে ওটা কি আছে স্যার? দেখতে পাচ্ছি না।
HACW into C. এই যে এইটা HACW into C.
ঠিক আছে।
ঠিক আছে। Now you see there are certain approximations. As this particular thing is required when the airplane is at the trimming condition, so we may consider alpha is relatively small, because the trimming alpha is relatively small, because it is only providing the lift to withstand the weight of the total airplane. Now you see, if alpha is small, I can obviously have cos alpha approximately 1 and sin alpha approximately alpha. That will render this particular equation to come as this, and corresponding coefficient will be provided as this. See if you are having any problem with these two. কিছুই করা হয়নি, only cos alpha to 1 and sin alpha is alpha, এটা বলা হয়েছে।
স্যার তারপরে এই সেকেন্ড ইকুয়েশনে স্যার করেসপন্ডিং কোএফিসিয়েন্ট দিয়ে রিপ্লেস করে দেওয়া হয়েছে, তাই তো?
একদম।
ওকে স্যার।
Now you see there are further approximations. First of all, what you think this particular Z, will it be very high? The vertical distance, can we say that the vertical distance is negligible in place of the horizontal distance?
Yes sir.
Yes sir, we can neglect.
So Z we can neglect. That is at the onset. And at the second case, you see this particular term CDW into alpha. CD is by default very much less than CL, and CD into alpha, when both the quantities are less, very small, so the multiplication of two small quantities will provide you an even smaller quantity, isn't it?
Yes sir.
So this particular multiplication factor is very less than this CLW. And with these two approximations, the equation comes as this in the box. See the equation in the box. Any problem with this? Our বড়টা দেখাচ্ছি। From this equation, we omit Z, so this one out. we omit this one with respect to CL, so this is also gone. So what are left? This one, CL multiplied by this. Is it okay?
Clear, sir. Clear, sir.
Yes. Now you see, CMAC, will it be dependent on alpha? Will CMAC be dependent on alpha?
No, sir.
No, sir.
No.
Correct. Because that is aerodynamic center moment and that cannot be dependent on alpha. So for this particular equation, only there is CL what is dependent on alpha. CL is a function of alpha, to be honest. And what is the function? As we all know, the curve between CL and alpha, that is a straight line up to the certain limit. And obviously for our case, the trimming condition, CL must be well within the stalling limit. তাই তো রে নাকি?
Yes, sir.
স্যার আরেকবার রিপিট করুন কি বলছেন?
হ্যাঁ নিশ্চয়ই নিশ্চয়ই। What is the CL versus alpha curve? This is the CL versus alpha curve, isn't it? এটাই তো CL versus alpha curve নাকি রে?
Yes,
হ্যাঁ
sir.
স্যার, হ্যাঁ স্যার।
So for our case of small alpha, it is well within the straight line limit, that is well within the stalling limit, তাই তো?
Yes, sir.
So we can say that if the slope of this curve is A, then CL equal to A into alpha. বলা যায় yes or no?
Yes, sir.
Y equal to mx plus c, তাই হয় তো?
Yes, sir.
And as this is
Straight line.
absolute angle of attack, this passes to the origin, so c is 0, so y equal to mx, এর ইকুয়েশন তাই হবে তো?
হ্যাঁ স্যার, সিএল ইকুয়াল টু এইটাই হবে।
CL equal to slope into alpha. So what we have made is that CL is slope into alpha, and the slope we have termed as AW. And W means for wing, so slope is A. So CL is replaced by A into alpha. See if it is having any problem or not.
ক্লিয়ার স্যার?
Okay. Now we are coming to the point. See, in this particular equation, what are the quantities that you need to have from the wind tunnel data or corresponding CFD data? কটা quantity রয়েছে বল? How many things are there that you need to have from the tunnel data? You একটা বল?
এই লাস্ট এক্সপ্রেশনতে?
Yes, from the last expression.
Sir, alpha.
Alpha you need not have from the equation. Alpha is a variable. You see, there are other things. How are you going to get CMAC wing? How are you going to get it, man?
ওই ইন্টারনাল এক্সপেরিমেন্ট ডাটা থেকেই তো পাওয়া যাবে।
Yes. So the first term you have to get from the experimental data, isn't it? What is the slope? The curve for CL versus alpha that I have shown you. This curve will be there, and how to achieve this particular curve? This is also coming from the wind tunnel data, isn't it?
Yes, sir.
So the slope also comes from the wind tunnel data. Okay, fine. What is H? H is the distance of the CG from the wing tip. So that is not coming from the wind tunnel data. That can be provided by the airplane manufacturer. ঠিক আছে? Isn't it? These
Yes,
H
sir.
can be provided by the airplane manufacturer.
Yes.
But the last term that indicates the position of the aerodynamic center, and that is also coming from the wind tunnel data. Think about it. This HACW, that is the position that denotes the position of the aerodynamic center, right? And that also comes from the wind tunnel data.
স্যার তার মানে তিনটে
Yes.
ডেটা।
So there are three terms in this particular equation which actually is provided by the wind tunnel data or the CFD data only. You do not have it in your own hand. দেখ কথাটা বোঝা গেল কি? Is it okay?
স্যার সিএমএসিটা কিরকম ভাবে পাচ্ছি ইন্টারনেট থেকে আরেকবার বলবেন?
আমি এর আগে একটা কার্ভ দেখিয়েছিলাম। there are certain curve for wind tunnel data of certain aerofoils.
Yes, sir.
Ultimately CMAC বলে যে জিনিসটা রয়েছে, that is the moment about aerodynamic center, না?
Yes, sir.
And from the first chapter, how do you know that the moment is provided from that particular integration, isn't it? কিরে ভুলে গেছিস?
না স্যার, দেখছি নোটসগুলো একবার।
First chapter কি ছিল? The moment and the force, all the things are provided from those particular integrations.
Yes, sir. Yes, sir.
তাই তো?
Yes, sir.
So in order to get on with those integrations, you need the wind tunnel data, isn't it?
Yes, sir.
So is it clear that this particular thing will be from the wind tunnel data only?
Yes. আর বলছি স্যার, স্লোপ যেটা আছে ওটা কি এ ডাব্লিউ ইন্টু আলফা ডাব্লিউ একসাথে প্রোডাক্টটা?
No, only AW is the slope. Alpha W to alpha W, that is the angle of attack.
ওকে স্যার।
Okay, so up to this, is it okay?
হ্যাঁ স্যার।
Okay. Now you see that people started thinking of that for this particular total thing, we have considered the wing only, right? But the total thing was this. We have the wing, next we will have the tail, that is absolutely fine. But the body shape itself are having some sort of effect on this particular lift, drag, and all these things.
স্যার এয়ারপ্লেন বডিটা বলছেন না?
Yes, the airplane body. The airplane body is also a streamline shape, and that particular thing will also have some belongings about these sort of forces. But that is not very regular. Okay. Some effect will be there, but that will be not very regular. বুঝা গেল কথাটা?
Yes, sir.
So what they actually suggested is, instead of the model of the wing only, for having those three wind tunnel data, let us have a model of the wing body combination. That is a body connected two wings are there, the tail is not there, obviously. So the model of a body with two connected wings are tested in the wind tunnel in order to get those three data: CMSCW, AW, HSCW for the wings. Now you may ask me why this is done. If the wind tunnel data is obtained using such a wing body combination, then the effect of body will be incorporated by default.
স্যার একটা কোশ্চেন ছিল।
Is it
Hello?
okay or not?
হ্যালো,
হ্যাঁ হ্যাঁ,
বলছিলাম তো আমরা টেলের কন্ট্রিবিউশনটা কেন নেগলেক্ট করছি? লাস্ট ক্লাসে তো দেখা হলো
এটা আলাদা করে নেব। টেল ইজ ভেরি ইম্পর্টেন্ট ফ্যাক্টর না, সো টেল উই উইল
Yes.
কনসিডার সেপারেটলি।
ওকে স্যার।
But the contribution of the body can be taken care of in this way, na? That when we are actually having this data, we test the wing body combination in the wind tunnel to get this particular data. That we can do, na?
Yes, sir.
হ্যাঁ স্যার।
So if we do this thing, you see, we are having these equations with the suffix changed from W to WB. এটা সাফিক্স গুলো W ছিল, তাই তো? All the suffix were W, AW, alpha W, and all these things. When we get this data from the wing body combination, all the suffix changed to WB instead of W, denoting wing body.
Yes,
So
sir.
is it clear?
Yes, sir.
Okay.
স্যার টেলটা ইনকর্পোরেট করলে তো ইকুয়েশনস এর
আচ্ছা।
মধ্যে কিছু চেঞ্জ আসবে,
We are
তো সেটাকে
coming
আমরা
to the tail. We are coming to the tail. Wait. আচ্ছা ঠিক আছে, কি বলছিলি সেটা আরেকবার বল।
হ্যাঁ বলছিলাম যে টেলটা ইনকর্পোরেট করলে এই যে সিএমসিজির এই ইকুয়েশনস গুলোতেও তো কিছু চেঞ্জেস আসবে, তো ওইগুলোকে আমরা এখানে নেগলেক্ট করে দিচ্ছি না
না,
ওই
নেগলেক্ট
পসিবিলিটি
করবো না তো,
গুলোকে?
এবার টেলটা আসবে, দেখ না।
আচ্ছা,
This is for the wing body combination only, okay?
ওকে।
Tail has yet played no part, but now tail will play. So now let us come to the contribution of tail. Okay, this was your point, na?
হ্যাঁ স্যার।
So in order to have the consideration of tail, first of all, tail is already at a negative angle, that is called the tail setting angle, that I already told in the previous class why it is in a already negative position to have a negative lift, right? So,
Yes, sir.
and this is, I am not sure how much visible is this, but the angle is called IT, tail setting angle, IT, okay? And what happens to the V infinity? It is seen this V infinity is not the V infinity negotiated by the wing, because it is the disturbed quantity, disturbed entity behind the wing itself. তাই তো রে নাকি? That I made clear na, that in the previous class, that if it already negotiates the wing, behind the wing it is not V infinity again, that is a disturbed
Yes, sir.
flow.
Yes, sir.
And omitting the most of the disturbance, at least one thing is noticed, is that E infinity is actually deviated downward by an angle epsilon. Why this is deviated downward, that I will come in the next class. Okay, that is not directly associated to flight dynamics, but I will discuss it because otherwise it won't be clear to you.
Okay, sir.
But for now, admit it that it is seen that V infinity is deviated downward by an angle epsilon. Okay.
Okay, sir.
So that obviously causes the lift and drag force to be deviated by the same angle, isn't it? Because the lift and drag are perpendicular and parallel to the p-string velocity.
Yes, sir.
हाँ सर
If that is deviated by epsilon, these will always also be deviated by the value of epsilon, isn't it? And what happens for the wing case? What was the angle? That was alpha w or alpha wb, you can say. তাই ছিল তো রে নাকি?
Yes,
हाँ
sir.
सर
হ্যাঁ স্যার
Now it is alpha wb minus epsilon. Okay. কি ঠিক আছে তো নাকি?
Yes, sir.
Okay. So what are the forces
Sir-
associated?
মাইনাস কেন হচ্ছে স্যার প্লাস হতে পারে না
আরে প্লাস হবে কোন কি করে হবে? নিচে নেমে গেছে। ডেভিয়েটেড ডাউনওয়ার্ড তো কি করে প্লাস হবে?
हाँ सर ओके सर
So there are two forces LTDT and one MACT on the tail. And about the CG, the forces will have this particular equation for moment. MACT will be there and the vertical component of the forces LT cos and DT sine of the angle is at a distance of small lt from the center of gravity. Okay, and the other two are at a vertical distance of zt. So see the equation. Anybody having any problem, tell me. And if everybody is okay with this, just tell me to continue. Should I continue?
Yes, sir.
Okay. Now you tell me that the horizontal distance, that is the distance between the CG and the tail, that will be way higher than the vertical distance Z, isn't it?
Yes, sir.
So we can here also we can omit ZT with respect to LT. So that is gone. Alpha wing body was by default small, and if it is now alpha wing body minus epsilon, that is even smaller.
हाँ सर
So here we can take the sine of this is 0 and cos of this is 1. So
স্যার
if we
আরেকটা ড্র্যাগ আপ টেল ইজ মাচ লেস দেন লিফট আপ টেল না
see the second one, na, drag is very less than lift. Actually this is a redundant simplification. You see, if you put sine alpha equal to 0, then this is by default gone, isn't it? তাই তো রে?
Yes.
If you take sine alpha is 0, then the second term is by default gone, তাই না?
Yes, sir.
हाँ सर
হ্যাঁ হ্যাঁ
And if you omit zt, the fourth term is again gone.
हाँ सर
So The second consideration, that is obvious again, drag is less than lift, but that is very much not very much relevant for this particular simplification. Any term of dt by default won't be there. We may say that zt is small, dt is small, so the multiplication is even smaller, so we omit. In this way we can say. But still, zt terms are by default omitted. Okay. বুঝা গেল কথাটা?
Yes, sir.
हाँ सर
So only one term is left behind. And also, as tail is very small in size, the moment about aerodynamic center is also not very significant. It is seen that we can omit MACT also. So only one thing is left behind. That is LT into LT. This particular. Remember that I already told that as we are having some negative lift in the tail, so that will ultimately make it positive. তাই তো রে?
Yes, sir.
हाँ सर पॉजिटिव
So from the MCG, we again want to go to the CMCG, the coefficient, তাই তো নাকি? Yes or no?
Yes, sir.
हाँ सर
But here is a problem. You see, if we are finding out this particular thing for the tail, then the CL of t will be given by this LT by Q infinity into ST, তাই তো নাকি? But can you really normalize MCGT with respect to tail only? Cause you actually normalize the wing body combination with respect to the properties of wing. Isn't it?
Yes, sir.
So if you are going to sum this up, you need to normalize MCGT also with the properties of wing, but not with the properties of tail. So fine, we are finding out CLT, and in place of LT, we put the value of CLT to get this. So the third equation is okay for you or not? আমার মনে হয় এটা খুবই সহজ. Just we have put CLT Q infinity ST in place of LT.
Yes,
हाँ
sir.
सर
Now we normalize it with respect to Q infinity SC. Those are the properties of the wing only. So we are,
স্যার এটা বোঝা গেল না স্যার কেন আমরা টেল দিয়ে করছি না উইং দিয়ে বডি দিয়ে কেন করছি
cause we need to sum this up with that particular coefficient. যে কোশ্চেনটা তখন করলি, that this is the combination for wing and body. What is the combination of, what is the purpose of tail then? So the tail contribution is to be sum up with this particular thing, na? And
বোঝা
can
গেল
you
স্যার
sum up to differently normalized things?
ক্লিয়ার স্যার ক্লিয়ার
So in order to do it, we are left out with such a particular thing, this LTST by CS, such a constant thing will be there. We have no problem in it. We are saying this particular constant VH and write it in this way. That is having no problem. And again, what is your CLT? Your CLT is again 80 into alpha t, just like the wing. Now what is your alpha t? The angle is alpha wing body minus epsilon, right?
Yes, sir.
And tail is by default at a negative angle it. So the net alpha t will be this alpha wing body minus epsilon minus it. Is it okay?
Sir, alpha wing body minus epsilon to almost zero to.
আহা সে হোক না, আপাতত ওটা হবে কিনা বল।
Yes, sir. Yes, sir.
জিরো হতে পারে, জিরো তো নয়, মানে ভেরি স্মল কোয়ান্টিটি।
Yes, sir.
But as far as expression is concerned, this will be there or not. The expression is correct, na?
Yes, sir. Yes, sir.
So IT, what is IT? IT the tail setting angle that I have got from the airplane data. So IT is of no problem. Alpha wing body I know already. But epsilon, do we know what is epsilon? Epsilon I don't
Epsilon,
know. That is the radiation angle. I really do not know epsilon, right?
No, sir.
right, sir.
So for epsilon again, we need to go back to the wind tunnel data. And as we have no particular data about epsilon, we have found epsilon with respect to alpha, and I may assure you the curve is exactly similar to this particular curve. দেখতে পাওয়া যাচ্ছে সিএল ভার্সেস আলফা এ নয়, সিএল ভার্সেস আলফা যে কার্ভটা এটার মতো অনেকটা।
সিএল ভার্সেস এপসাইলন হয়ে যাবে তাহলে।
হ্যাঁ, this will be epsilon versus alpha will be look like this. Where for alpha equal to 0, that will have a certain value, and next that will be a straight line. Obviously এই জায়গাটা থাকবে না, this part won't be there. There will be a certain value of epsilon even for alpha equal to 0, and then that will increase in a straight line.
কার পোরশনটা থাকবে না, তাই তো?
Equation to be epsilon 0 plus slope multiplied by the x-axis value of alpha. দেখেন কারো কোনো সমস্যা আছে? If anybody having any problem, please let me know.
স্যার বলছিলাম যে এপসাইলনটা তো আলফার ফাংশন হচ্ছে, আর এর আগে আমরা দেখলাম কি আলফাটা তো ভ্যারিয়েবল হচ্ছে, সেটা আমরা উইং টানেল ডেটা থেকে পাচ্ছি না। তো স্যার এপসাইলনটা আমরা উইং টানেল ডেটা থেকে কি করে পাবো?
আমি তো আলফাটাকে আলাদা করে পাচ্ছি না, but the variation is there, না? I can get the epsilon 0 and del epsilon del alpha. These two term I can get from the wind tunnel data, isn't it?
হ্যাঁ স্যার।
ওইটাই আমার চাই, অন্যটা চাইছি না। I need this particular value of epsilon 0 and del epsilon del alpha that we can have from that particular curve, na?
হ্যাঁ স্যার, স্লোপ এন্ড ইন্টারসেপ্ট স্যার।
Exactly. So instead of epsilon, we put this particular thing, and if instead of epsilon we put this particular thing, we get CLT as this, and CMCGT is minus VH into this, so CMCGT is going to be this. Check those two equations. I don't think it is at all very complicated. That is okay. Just we have put epsilon as this in this particular equation. May I continue?
Yes, sir.
Continue, sir.
So this CMCG-T will be added to the CMCG wing body to get the total contribution of the wing body as well as tail about the CG. And that will have the equation to be this particular thing. Just দুটো যোগ করে লিখে দেওয়া। Just we have summed up and we have kept it here. Follow these equations. The second one mainly the second one. Follow the second one. This one. You see all the 4 terms are here. 2 terms from the wing body data and 2 terms from the tail data. Is it all right?
Yes, sir.
All right, sir.
Now you see what are your requirements? CM0 is positive, right?
Sir.
So what will be the value of CM0 from this equation? Can you predict? From this equation, can you predict what is CM0? It is not very difficult. সবাই চুপ করে গেল। আচ্ছা, what is the meaning of CM0?
The moment coefficient at wingtip.
আরেকবার।
Moment coefficient at wingtip.
Moment coefficient at
Wingtip যেখানে শুরু হচ্ছে wingtip.
কত ভাগা? Moment coefficient for lift equal to 0 is the CM0. আরেকবার দেখাচ্ছি, সব ভুলে গেছি। What is CM0? CM0 is CMCG at alpha equal to 0. And alpha equal to 0 means lift equal to 0, isn't it?
Yes, sir.
Sir.
So now you say, from this equation, can you predict CM0?
Yes, sir. By putting lift value equal to 0, sir.
Yes. So if alpha is 0, then this term will go out. Right now.
Yes, sir.
So what are the 2 terms there? This one and this one.
Yes, sir.
Now think about our previous class, as we already told that the moment about aerodynamic center, the coefficient of moment about aerodynamic center is negative. বলেছিলাম তো নাকি? It was told, na? It was shown that the moment coefficient about aerodynamic center is negative.
हाँ सर बोला है।
So this term is negative. Yes, the first term is negative, right?
Yes, sir.
Right.
So what are the next term for CM0? This one.
हाँ sir.
So this term must overcome this term in order to make CM0 positive.
Obviously, sir.
And what is the second term having? that is the tail setting angle IT, তাই না?
Yes, sir.
হ্যাঁ স্যার।
And that is in your hand or my hand.
হ্যাঁ স্যার।
I can set the tail accordingly, yes or no?
Yes sir.
So are you guys convinced that the tail setting angle is the sole responsible of making CM0 positive?
হ্যাঁ স্যার।
Other things we cannot actually change at our own will. বোঝা গেল কথাটা?
হ্যাঁ স্যার।
Yes, sir. Yes, sir.
And what is the next requirement? Second necessary condition কি? Del
Sir,
CMC
slope-টা
del alpha to be negative.
হ্যাঁ স্যার।
What is the value of del CMCG del alpha from this equation? এই এটা খুব সোজা।
ওটা তো 0 হয়ে যাচ্ছে।
The first term is 0, এটা 0 হয়ে যাবে তাই তো?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
এটার থেকে কি আসবে? del alpha করলে AWB multiplied by this third bracket term,
হ্যাঁ
and the final term will again get to 0. This is constant. কি বোঝা গেছে? Yes or no?
হ্যাঁ স্যার বোঝা গেছে।
ওই ভেতরটা ডেল স্কোয়ার সিগমা বাই ডেল আলফা স্কোয়ার হয়ে যাবে তো।
আরেকবার
ওই যে ভেতরে 1 মাইনাস ডেল এপসাইলন বাই ডেল আলফা আছে,
হ্যাঁ,
ওইটা ডাবল
del
ডেরিভেটিভ হয়ে যাবে।
del alpha is constant. This is the slope.
ওকে ওকে
This is
হ্যাঁ
the slope. This is the slope of the alpha epsilon versus alpha curve. So that is by default a constant.
ওকে, তো ওটা 0 হয়ে যাবে ওটা।
কেন 0 হবে? এই পুরোটার সাথে তো এটা রয়েছে মাল্টিপ্লিকেশন।
ওকে।
So del epsilon del alpha will render AWB multiplied by the total term in the third bracket, isn't it?
হ্যাঁ স্যার।
So the term in the third bracket must be negative. কি রে, তাই তো? অন্য কিছু হবে?
Yes, sir. Negative.
From the terms of the third bracket, what is the term you can change? যেমন বাইরের টার্মের মধ্যে IT you can change. From the terms in the third bracket, what is in our hand? Think and say.
স্যার HAC wing body।
HAC wing is in your hand. How can it be? It is the position of aerodynamic center. That will be. আমি আরেকবার দেখাচ্ছি ছবিটা। What is in your hand? Tell me. কি ভাই, এই ছবিটা দেখে বোঝা যাচ্ছে না?
Sir,
স্যার
means
HC।
Yes. H is in my hand, more or less. More or less I can control H. I can change the position of this particular wing a bit front or left back, and I can change this H. Obviously not at my own will, but at best I can change this. H is not coming from the wind tunnel data. তাই তো? H is not coming from wind tunnel data, isn't it?
Yes, sir.
That is aeroplane manufacturer end, na?
Yes, but I can say the manufacturer that make it like this. Depending
sir.
on the other aerofoil data, the other wind tunnel data, I can actually say na that my H will be this. Yes or no?
Yes, sir.
Yes, sir.
So in order to ensure negativity of the terms inside the third bracket, can I say that H can have a maximum value, and the maximum value of H will be HSE wing body plus VH into this.
Yes, sir.
If H is beyond that value, obviously that will cause problem. তাই নয় কি?
Yes, sir.
H must be less than that value. কথাটা বোঝা গেল?
হ্যাঁ স্যার।
And that particular value of H, we say the neutral point beyond which that may cause no longitudinal balance of the airplane. So is the case clear?
Yes, sir.
স্যার লেস ইকুয়াল টু হতে পারে কিন্তু গ্রেটার হলে প্রবলেম হবে, তাই তো নির্ভর করে
একদম।
বলছেন।
We must keep H within that limit. ঠিক আছে, বোঝা গেল?
হ্যাঁ
Yes,
স্যার।
sir.
হ্যাঁ স্যার।
So now please go through the chapter 7 of the book of flight that is already provided to you. All the things are given there. In the next class, first of all, we will try to know that why such deviation of V infinity occurred. And next we will carry on. Okay.
ওকে স্যার, থ্যাংক ইউ স্যার।
So let us end for today.
ওকে স্যার, থ্যাংক ইউ স্যার।
Okay.
গুড নাইট স্যার।
Anybody having
Good
any
night, sir.
স্যার হ্যালো
হ্যাঁ বলো।
স্যার, বলছিলাম এই মানে ফিজিক্স প্রবলেমের ফিজিক্সটা তো বোঝা যাচ্ছে, কিন্তু স্যার এই এক্সপ্রেশন গুলো তো স্যার এই দেখে কমপ্লেক্স মনে হচ্ছে, কনভার্সন।
আগে আগে বইটা পড়ো, তারপর যদি কমপ্লেক্স মনে হয় তখন বলবে।
ওকে স্যার।
বাবা প্লেন উড়বে আর ইকুয়েশন গুলো একটু কমপ্লেক্স হবে না, তা কি আর হয়?
ঠিক আছে স্যার।
ঠিক আছে, so let
Okay,
us end for today.
ওকে স্যার, গুড নাইট স্যার।
Yeah, good night.
Good night, sir.